Java is an object-oriented programming language. You can't get very far in Java without having at least a basic understanding of what an object-oriented programming language is and how classes and objects work. So this chapter is an overview and introduction to working with classes and objects. And in this lesson, I'm going to give you a brief overview of what object-oriented programming is and what classes and objects are. So let's get started. An object-oriented program is a collection of loosely connected objects interacting with each other. For example, in a payroll program, you have a set of employees. Each one of those employees is an object, and you have a payroll, which is itself an object. You can also have other objects in the program as well, such as a timesheet, or the number of hours worked could be an object, although it's usually just a piece of data. But you get the idea. And those objects interact with each other even though they are defined independently. An object, or a class, encapsulates state and behavior. When we talk about state, we're talking about data, and when we talk about behavior, we're talking about the operations that that object can perform using either the data that's inside the object or outside data as well. A class defines an object's behavior, so we create a class so that we can define exactly what an object does. Once we create a class, then we can create individual objects of that class. So for example, in a payroll program, we'll have one employee class, but many employee objects, all of the employees that are going to get paid within that payroll. For all intents and purposes, a class can be viewed as a user-defined type. So even though Java does not have a built-in type for employee, we can create one in Java by defining an employee class. Classes can be linked to each other using a hierarchical structure. So for example, if I have a top level class, sometimes called a superclass, of employee, then underneath that employee class, I could have a hourly employee class and a manager class that inherit the characteristics or the common characteristics of the employee class. So for example, both an hourly employee and a manager have a name and a date of hire. But an hourly employee will have one salary structure and a manager will have a different salary structure. So the hourly employee and the manager can inherit those characteristics that are common, and then it can have their own definitions for those characteristics that are distinct. Classes higher up in the structure can pass state and behavior to lower classes, which is pretty much what inheritance means, is that I can take the characteristics of an employee and pass those down to lower level classes such as an hourly employee or a manager. An object-oriented program is a collection of objects where each object has its own set of responsibilities. That's what makes object-oriented programming such a great tool for managing large complex programs, because with each object I can concentrate on its responsibilities rather than have to worry about all the objects at once. So each object can be defined independently and then brought together to create a more complex whole. Objects form the basis of reusable software, since an object can be used in any program that needs the object. So for example, I have an employee object that I use in my payroll program that I can also use in a project management program or a human resources program or any other program that my company has to write that involves working with employee objects. This lesson was meant only to cover the very basic concepts of classes and objects and object-oriented programming. The rest of the chapter will involve actually creating our own classes to see how it's done and begin to get a better idea of how Java works as an object-oriented programming language. So in the next lesson, we'll begin by learning how to define a class. The best way to talk about classes and objects is by looking at a specific example. So in this lesson, we're going to begin building a name class to keep track of a person's name, which will include the first name, the middle name, and the last name. So let's get started. Open a DOS window, navigate to your Documents Java folder, and then let's work with the template file. So if you saved a template file, open that up by typing Notepad in the name of your template file. Mine is called template.txt. What I want to do here is change public class template to public class chapter 5. Everything else can stay the same, and then we're going to do a file save as. Remember, our file name has to be the same as our class name, so it's chapter5.java. Be sure to go to Save as Type and change that to All Files, and click Save. And now we're ready to begin. A class definition begins in the section above public static void main. In other words, before, or it could be after, the main program. So put a line between the opening curly brace for chapter 5 class and public static void main, and then indent and write public class name, like so. Drop down to the next line and put a opening curly brace to signify the beginning of the class definition. Skip down to the next line, indent, and again, indentation is important to make our programs more readable. When we define a class, we define two parts, the data part and the behavior part, which we're going to call methods starting in this lesson. We'll begin with the data. A name consists of three parts, a first name, a middle name, and a last name. We're going to declare variables for those parts right now. Private string first for my first name. I'll explain what private means in just a moment. Private string middle for the middle name, and private string last for the last name. When we declare a variable as private, we're saying that the exposure of the variable is only within the definition of the class and not to any other part of any other program. I can't really explain much more than that until we can actually create an object from this class. So for now, just take my word for it that we want first, middle, and last to be private variables. And I'll explain more about what that means later. After your variables, then you can create methods or behaviors. For a name, that might include something like displaying the name or displaying the initials. So I'm going to demonstrate those two methods now, and we'll perhaps look at others later. Methods are public, so we'll declare those as public. We'll do display first. A method always begins with the return type of the method. In other words, a method returns data. So if I'm going to create a method called display name, it's going to return a string, and that string will be the name in the object that we're working with. So we write public and then string for the return data type and then the name of the method. So I'm calling this method display name. We use the same rules for methods as we use for variables. Then I'm going to put a open and close parentheses after that. That signifies that I'm not providing any data to this method. Think of a method like a function. A function can have data that you're going to manipulate and return as something else. For example, when you double a number or when you compute the absolute value of a number. In this case, we don't have any data, so we're just going to put open and close parentheses because we want to display the name. Put an open curly brace to signify the beginning of the definition of the method. Indent, and then write the keyword return. And I'll explain that in a minute. And then write first the plus sign, a space, which is an open quote, space, close quote, another plus sign, the middle name, another plus sign, another space, and then the last, or the last name, the variable last. Type a closing curly brace to signify that the definition is over, and we've defined our first method, display name. Return just tells the compiler to return whatever expression follows that. The expression is a concatenation of the first name plus a space plus the middle name plus a space plus the last name. So it's first, space, middle, space, last, space. Then we close off with a closing curly brace. Let's write one more just for the practice of it. We'll write public string get initials. And again, we don't pass any data to this. We just have open and close parentheses. An open curly brace, indent, and then type return first dot substring 01. I'll explain that in just a minute. Plus middle dot substring 01. And then just to make this easy to read, drop down to the last line, type a plus. It doesn't have to be right under the F. I'm just putting it there. Plus last dot substring 01. Semicolon to signify the end of the statement, and a closed curly brace. Substring is a string method built in that returns a substring from a string. The arguments, or the data that we pass in, the first one is the starting position, where we want to pull the substring from. The second argument is the number of characters we want to pull in the substring, or from the original string. I want to get the first letter of the first name, so I write substring 0, 1. I want to get the first letter of the middle name, so again I write substring 0, 1. And then because I also want to get the first letter of the last name, I also write substring 0, 1. We're finished with our class definition at this point, so I have to type another closing curly brace to signify the end of the class. And then I'll put a space between them. We're still not quite ready to create an object of this class. We're going to save that for another couple of lessons away. But let me review what we've done in this lesson. We're creating a class called name. This class will store a person's full name, their first, middle, and last name. We created 3 variables, also called members. Later in the course, we will break down this terminology in much more detail. So sometimes I will call these variables, and sometimes I'll call them members or even fields. One thing you're going to learn about object-oriented programming is there's lots of terminology, and a lot of it is not consistent. So we have 3 members or fields. I'll try to use the object-oriented terms. They're private because we do not want them to be exposed to any other parts of the program other than the class definition. And again, I'll explain that in more detail once we can actually create objects of this class. And they're all 3 strings, so we use the string data type. Then I created 2 methods, which are just operations that we can perform on the data in the class. The first one is called displayName. It returns a string, which is a concatenation of the first name, the middle name, and the last name, with the space in between each. And I just chose that arbitrarily. I could have picked last name, comma, first, middle, or some other configuration. I just chose to make it simple by making first space, middle space, and last space. And then the second method I created is getInitials, and it returns a string that consists of the first letter of the first name, the first letter of the middle name, and the first letter of the last name. And I got those letters by calling a string method that's built in called substring, which pulls a given number of characters from a given position in the string. So 0, 1 says pull 1 character from the 0 position of the string. I should also mention that in Java, strings are numbered, their positions, starting at 0. So the first position of a string is always position 0. That's why this first argument is 0. As I mentioned before, we're still not ready to build objects or create objects of this class. We still need to learn how to create one more type of method called a constructor, and we're going to look at how to create constructors in the next lesson. After we've declared the data members for a class, the next step would be to create what are called constructor methods. Let me write that out for you. I'll put it in a comment here. Constructor methods allow us to instantiate or declare a class object and provide that object with some data. Constructor methods are always declared as public, and they're also always declared using the same name as the class. So we start out by writing public name, and then we provide parameters or arguments for the pieces of data that we want to provide to the class object in this constructor. So what I'm doing here is creating 3 parameters, F, M, and L for first name, middle name, and last name. So I close off the parameter list with a closing parenthesis. Then I come down and add an opening curly brace, move down a line, and all we have to do here are simple assignment statements where we write first equals F, middle equals M, and last equals L. And that's an L, not a 1. Sometimes it looks like a 1, but it's an L. So that constructor will be used to create a name with the first, middle, and last name. I say that because it's also possible to create more than one constructor. We can create a second constructor using the same beginning, public name, and in the parameter list I have to provide a different number of parameters than the one I did before. So for example, in the first constructor method I had 3 parameters, F, M, and L. For the second constructor I can only have 2 parameters, F and L. So what we'll do is we'll assign F to first, And then for middle name, we'll just assign the empty string since a parameter was not provided. And for the last name, we'll do L. Now, it doesn't make much sense, but just to demonstrate and kind of stress this fact that we can have multiple constructors of the same name, we'll create one last constructor with just the last name. So we'll say first is equal to empty string, middle is equal to empty string, and then last name is equal to L. The reason we can have multiple methods with the same name is due to a feature of object-oriented programming languages called overloading. When you overload a method, you're saying that I'm going to use a method with the same name, but I'm providing a different set of parameters than any of the other methods with that same name. So you see I have 3 methods all named name, but each one has a different parameter list. This first constructor method has 3 parameters, the second method has 2, and the last one just has 1. That's how the compiler is able to differentiate between method calls with the same name, is by looking at the parameter list. And then it can flesh out which method you're trying to use or which constructor method you're trying to use based on which parameter list it's looking at. When we call a constructor, we provide it with data, and then that data is assigned to the object that's created in the declaration statement. We're going to demonstrate that in another lesson or two, but I just wanted to point out what we're doing with the constructor. Before we leave, though, let's look at one last example. We can also have what's called a default constructor. And a default constructor has no parameters, and it simply assigns each data member a default value, usually based on that data type. So for a string, the default value for a string is the empty string, just like the default value for an integer would be 0, or for a double as well. So this way I can create a name object without assigning it any data at the time if for some reason I need the object without any data in it. So it's always a good idea in any class that you create to add a default constructor to the definition. Interestingly enough, the compiler will provide a default constructor for you if you don't provide one yourself, but it's usually a good idea in a class definition to go ahead and make the default constructor explicit so that someone looking at the class definition will understand exactly what's happening when the default constructor is called. So that wraps it up for constructors. That's just about all we can talk about, certainly at this stage of the course. Now we'll move to the next lesson in this chapter, where I'm going to create one more method so that we can display the data from a class, and then we'll also learn how to create name objects through a process called instantiation. We're almost ready to use the class. We just need to add at least one more method so that we can display the data that we've put into an object with the constructor. So we're going to write a method called toString. The toString method will pull out the first, middle, and last name of a name object in that order. And that's an arbitrary decision. We don't have to do it that way. We could choose some other way to return the name, but just as easy as anything else and probably makes the most sense. We could write other methods to display the name, last name first, or display just the initials, and at some point in time we probably will write some of those methods. But what we want with toString is just a very basic representation of the data in an object, sometimes called the state of the object, that we can look at any time. So that's what we're going to do with toString. So now we're ready to work with this name class. So what we need to do first is save the file. I'm going to go back to our DOS prompt, and we need to compile it. So we're going to write javac name.java. Hopefully it will compile without any errors, and it did. So that means the class, at least syntactically, is correct. So now we're ready to see if it really works. So what we need to do is create another program, a test program. So we're going to call it nametest.java. Sometimes these are also called driver programs, but I like test a little bit better. So it's public class nameTest is the name of the class. Public static void main string args. I could have used my template file, but it's just as easy to type it in. So here's where we begin to create the class. Declaring a class object and assigning data to it is a process called instantiation. Let me write that out as a comment. Because what we're doing is we're creating an instance of the name class. And the way we do that is by writing the class name, followed by the name of the object we want. We'll call this one my name. Then calling the constructor, which means using the assignment operator, followed by the keyword new, followed by our data. So I'll put my name in, like so. When this line executes, my name will be an instance of the name class, and the first name will be Michael, the middle name will be Mason, and the last name will be McMillan. Let's create another object. This time we'll call the second constructor we created, like so. Let's instantiate a third object. Well, let's call this a name equals new name, and then we'll just use the third constructor. And then finally, now let's look at how we can display the data from those name objects. System out print line. And to call the toString method, we use my name, followed by a period or dot, and then the method toString. Let's check this to see if it works before we go any farther and look at the other name objects. So let's close out the program with our closing curly braces. Save the file. Go back to our DOS window. I'll leave it on top. Let's clear the screen because it's getting a little messy there. And type javac nametest.java. Came back quickly. So type Java nametest. And there we see that my name has the values Michael, Mason, McMillan. Let's do one more just as a proof of concept. And we'll do your name. And so we call toString with your name.toString. And notice I use the open close parentheses with methods that don't require any parameters. That's one of the features of Java. Some languages don't require that. Save the file. Compile it again and then call it. And so my name has the data values Michael, Mason, McMillan, and your name has the data values Raymond, empty string, Williams. Notice that there's an empty string between Raymond and Williams because that's what the constructor assigned to the middle name when we only provided a first and last name. Let me bring the program back up so we can take a look at it. So to review, when we instantiate an object, we declare an object just like we would declare a primitive data type, but then we call the constructor by using the keyword new followed by the class name. And then the arguments to the constructor will be whichever set of data we wish to provide to that object, either a full set or a partial set or an even less or more partial set, depending on how you look at that. And then if we want to display the data, we have a method to do that called toString, which gets called by using the class object name, my name or your name, followed by the dot operator, followed by the method toString. And even though we don't have any data to pass into the method, we still use the open and close parentheses. That's how you initially assign data to your class objects. But there's other ways to do that using what are called getter and setter methods, well, especially setter methods for setting data, and getter methods are also used to return data from a class object. And we're going to look at those two types of methods in the next lesson. For this last lesson in this chapter on classes, we're going to create a set of getter and setter methods. These are called getter and setter methods because they're used to get data out of the class object and to set the data members to a particular value. So let's get started. We'll add these methods under our toString method. So we'll start out with the getters. They will always be string functions. In other words, because our data members are strings, then these will return strings. So we'll call the first one getFirst, and all it does is return the first name. You can see that the other ones are going to be similar to that. So we'll do public string getMiddle, return middle right here, and then getLast. These methods will return the value specified in the method name. So we have getFirst for the first name, getMiddle for the middle name, and getLast for the last name. Now we're ready to do the setter methods. Setter methods will be used to set each data member to a particular value. That way, if a name object has a change, for example, someone specified by a name object gets married and their last name changes, we can do a setLast to change the last name. Set methods are void methods, and what I mean by that is a void method does not return data. it is simply used to perform an operation, in this case to assign a value to a data member. So its return type is void, which means no return type. So we'll write set first for the name of the method. The parameter will be a first name, that's a string, so we'll use string fname, and all we do is do a simple assignment. In this chapter, I'm not going to get into data validation. I'll do that in more detail when we get to the chapter where we study classes in more depth. Right now, I just want to give you an overview of how classes work. So we're going to avoid worrying about data validation. So after set first, we need to set middle. Middle equals mname. And then our last one, public void set last, string lname, last equals lname, like so. To take us down to the end of the definition. Let's go back over these real quickly. The getters return data members from the class object. So get first returns the first name, get middle returns the middle name, and get last returns the last name. Setters set data member values. So set first sets the first name to the parameter passed to it. Set middle sets the middle name to the parameter passed to it. And set last sets the last name to the parameter passed to it. Let's save this class. Open a DOS prompt. Compile it just to make sure it's working correctly. No errors, so everything's working good. So now let's call up our test program. I believe I called it nametest.java, like so. And let's play around with this a little bit. We'll use the initial values that we set, and I'm going to comment out this other code. And let's try a few things here. Let's do a let's use a get first. So let's say my name first name, and then we'll call my name get first, like so. And then let's do a set. Let's do a your name set last brown. I won't test them all. And then we'll do a toString on system out print line. I could have copied that from above, but at this point I might as well type it. I'm almost finished. So in this example, we're calling the getFirst method to get the first name, return it from the object my name. And then we changed your name's last data member to brown, and then we're going to return the whole name right here. Let's give it a shot. Save it. Open up our DOS prompt. Compile. Compiles quickly. Then run it in the VM by typing Java name test. So we return the first name for my name, which is Michael, and then we set your name's last name to Brown from Williams, and it returns Raymond Brown. Now let me go back and add one more setter method that I left out earlier. We'll just minimize that for right now. Here's my class definition again. I want to do a set name so that we can set a complete name. So we'll add it to the end of our definition. We're going to write public void set name, and then we're going to have string f, string m, and string l. First equals f, middle equals m, last equals l. Save the file. Bring our DOS prompt back up. Use the up arrow key to find where we compiled the name file right there, javac name.java. Compile it again. Everything looks good. Go back to our name test program, and where I have name some name, I don't have a name for that yet since I called it with the default constructor. We can use the set name method right here, so we can write set name, and we'll just use John Quincy Adams. Then we'll pull it out. In this case, I'm going to copy, not this one, copy this one and change what we want to change here. Control C, Control V, change that to some name, change it right here. All right, so to review what I've just done, I've created a set name method, and then I call it with some name to set the name to John Quincy Adams. Remember that in the previous lesson, I used the default constructor on that, so the current data member values were empty string. And then we call toString on some name so that we can see that it set the name correctly. So we'll save that file, minimize here and here. Takes us back to our DOS prompt. Compile name test. Oops, 2 errors. This was a good time to look at that So it says it cannot find the symbol. All right, well, I made a very simple mistake. Now we can find out what we did wrong. What we did wrong was we commented out our declaration of name some name. So let's add that in after our last comment right here, like so. Click File, Save. And that does account for both errors. We have two errors here, and both of them are because some name was not referenced. Cannot find symbol some name. As I go through the lessons, I want to mention this real quick. When I make little mistakes like this, rather than cover them up and edit and take them out, I'm just going to keep them in because these are the kind of mistakes you're going to be making as a beginning programmer. We all make them, and there's no shame in admitting it. And this way you can see how to fix these errors, or at least see how I fix them. And then when they come up in your own programs, this will help you be able to figure out what your mistakes are. So let's compile again. Still have, oops, I didn't change it every place. Let's see where it says it in set name in line 16. All right, let's go back to our code. Go back and check our main program. Oh, there's the mistake. Make that a capital. So you see how important little details like this are. Again, that's why I'm not editing this out. I want you to see where the mistakes are and the kinds you're going to make. Let's save that. Now we're going to have to recompile the name class. So we'll do this right. There it is right there. Now, recompile name test. One more mistake. It said some name may not have been initialized. Let's go back to our code and look. Default constructor, like so. Save the file. Compile again. Oh, all right. Some languages don't require you to put parentheses around the default constructor call like that. Let's try it one more time. There we go. Compile and run. There we have it. So let me talk one more time about this last error. The last error was the fact that I declared some name without calling the constructor correctly. I was actually doing it the way you do it in C++. To do it in Java, even though you're not using any data, you still have to call the class name or the constructor name with empty parentheses for a default constructor. So that was where the second error was. The first error was that some name had been declared in the file where the name is defined with the lowercase n, but I meant for it to be uppercase. That's just a typo. And actually, these are all just typos. So to summarize, let's go back to the definition, because that's where the important information is. We need what are called accessor methods to get at the data in our class, both to set it and to get it. So that's why we have getter and setter methods. And generally speaking, we will do that for all classes that we create if we want the user to have access to all the data. If we don't want them to have access to the data, we can leave a getter or a setter out if we need to. That's always up to the designer of the class and how they feel the interface of their class should work. And the interface just meaning what methods are available to the user to access the class objects. That ends our introduction to classes, and we're going to close up this chapter with an exercise, and that'll come up in the next video. We're going to end this chapter with an exercise. In this exercise, we're going to build a class. We'll build this class to keep track of a 2-digit month, a 2-digit day, and a 4-digit year. So begin by opening up a DOS prompt, get to your Java subdirectory, and then create a file for the class. We'll call it date with a capital D. Remember, you have to do that. .java. We'll begin with the standard opening, public class date, opening brace and a closing brace, just to go ahead and get those in there. Then move up to the empty space, indent, and then let's begin by defining our data members. Our first will be month. Then we'll have the day, and notice these are all integers since they are whole numbers, and int year. So that's not too difficult. After we've declared our data members, we can start with the methods of the class, and usually the first methods you create are the constructors. Well, let's do that. So our first one will be a constructor that allows us to enter a complete date. So we'll type int m, int d, and int y as the parameters for the function. And then month is assigned the parameter m, day is assigned the parameter d, and year is assigned the parameter y. Simple enough. Now let's build a second constructor that enters only the month and the year. So we'll say month equals m, day equals 0, since we want to use the default value for that data type, and year equals y. And then finally, let's build a default constructor where we set all three data members to 0. The month is assigned 0, day is assigned 0, and year is assigned 0. So those are the three constructors that we're going to use for this class. Now let's go ahead and write a toString method just to have that out of the way. So we're going to write public string toString, open close parentheses, and we're going to write return day. We'll do this with slashes. No, we're going to do the month first. I'm sorry. So let's do the month plus a slash plus the day plus a slash plus the year. And that will allow us to display a date once we put some data into it. Now we need to write getter and setter methods for each data member. So we'll begin by writing, let's do the getters first. So we'll do public int get month, return month, and then public int get day, return day, and then public int get year, return year. Now we'll do the setters. So public void set month, int m, month is assigned the parameter m, public void set day, int d, day equals d, and then public void set year, int y as the parameter, year equals y. And then close off our class definition. And that should be all we need. So we'll do a file save. Go back to our DOS prompt. Compile the class to make sure everything works correctly. Looks like we left one thing out. So let's go back to the class on line 63. Scroll down to 63. Already had a closing brace, so we don't need two for the whole class. So try that again. Recompile the program. This time it compiled. Now we need to build a test program to test our class. So we'll do that. We'll call the class datetest.java. Public class datetest. Public static void main. String open close brackets args. So let's create a couple of date objects. We'll say date today equals new date 5/4, 2011. And we'll write date tomorrow equals new date 5/2011. We'll fill that in a moment. Then let's display what we have. System out print line. Today is plus today dot toString. System out print line. Tomorrow is plus tomorrow dot toString. And then let's do a set day on tomorrow. Set day 5. And then we'll copy this out again. I did not provide a set date method. Be that I didn't do that. As I say, I'll leave that as an exercise for the viewer. Let's use the get methods to display the date. So we'll do today is again, and then we'll write today.getMonth plus a slash plus, let's drop down to the next line, today.getDay plus another slash plus today.getYear. Close the parentheses for the print line method and a semicolon. Close out the main method, then close the whole class. Click File Save. Go back to the DOS prompt. Compile. javac datetest.java. Everything looks good, so we run it. And so there we have today is 5/4/2011. The original tomorrow is 5/0/2011 since we didn't set the day. Then we added the day, so now it's 5/5/2011. And then we used the get methods to return today, and today is again 5/4/2011. So all the methods work correctly. We're going to come back to the date class later in the course when we start covering classes in more depth. There's a lot of extra functionality we could add to this class, of course, that will be very illustrative when we're discussing more in-depth topics. So you will see the date class again. Now we're going to move into the more of the nuts and bolts in Java, get away from classes, and learn how to perform arithmetic and learn about the arithmetic operators that are part of the Java language. That'll come up in the next chapter.